Astronomers have made the groundbreaking detection of two neutron stars colliding in a galaxy 130 million light years away. They detected the gravitational waves and the blast of radiation released from the collision, observing a kilonova for the first time. Now, I know we've been talking about gravitational waves quite a bit here on the Guide to Space, and a few episodes ago, I hinted at the tantalizing possibility the gravitational waves could maybe, perhaps, be used to detect colliding neutron stars. You know, once more sensitive instruments came online and physicists tweaked and tuned them, well, it turns out such a detection has already been made when I recorded that now hilariously out-of-date video. But it gets even better. At the same time, they detected the rippling distortion of space-time produced by the gravitational waves. Different teams of astronomers were actually able to watch blasts of radiation released by the neutron stars using every wavelength at their disposal. They detected the gravitational waves and then saw the collision in the sky. I promise you, this is one of the biggest discoveries of the year. So let's dig into the news. Late last week, the European Southern Observatory teased us that they were going to announce something on Monday, October 16th. We didn't know what it was, but they called it unprecedented. Okay, it got my attention. On Monday, we all learned what it was, and the reality lived up to the hype. At 8:41 a.m. Eastern Daylight Time on the morning of August 17th, 2017, researchers from the Laser Interferometer Gravitational Wave Observatory, or LIGO, detected the ripple of gravitational waves passing through the Earth. Now, unlike the previous colliding black hole observations, which lasted a couple of seconds, these ripples went on for 100 seconds, indicating that this event wasn't from black holes. Instead, it was tied to the collision of two neutron stars, the remnants of massive stars with 8 to 20 times the mass of the Sun that went supernova. 2 seconds later, NASA's Fermi Space Telescope detected a brief blast of gamma radiation with the signature of a short gamma ray burst. Now, the long gamma ray bursts are fairly well understood. They're tied to supernova explosions, but the short bursts have long been a mystery, although astronomers theorize that they had something to do with colliding neutron stars. In addition to LIGO, the Virgo interferometer in Italy also detected the gravitational waves passing through the planet. And with 3 separate observations, the researchers were able to determine the rough direction that the neutron star collision happened. An area in the constellation of Hydra covering several hundred full moons worth of area, with millions of stars and galaxies. They encouraged the worldwide astronomy community to go searching the region for the afterglow of the collision. From space, there was the European Integral Satellite, as well as NASA's Swift, Hubble, Chandra, and Spitzer observatories. Ground-based observatories across the hemisphere scanned the region, searching for a visual confirmation. The European Southern Observatory's 1-meter SWOPE telescope in Cerro Las Campanas in Chile was the first to find a new point of light located in the galaxy NGC 4993. And then other observatories followed up, viewing the spot across the entire electromagnetic spectrum, from radio waves through infrared to ultraviolet, as well as the space-based observations in gamma rays. All told, 70 different observatories were trained on the unfolding event using 100 different instruments. Until this point, LIGO had only detected merging black holes. And the problem with black holes, of course, is that they don't give off any radiation when they collide. Nothing escapes them. But neutron stars aren't massive and dense enough, so radiation can escape them. So there was an opportunity to find the explosion with the rest of the world's observatories. These two neutron stars had already experienced their share of catastrophe. In previous lives, 11 to 12 billion years ago, they were both hot, massive stars that died as supernovae, one, then the other. And the neutron star remnants orbited around one another ever since, getting closer and closer for billions of years. One neutron star was 10% more massive than the Sun, and the other had 60% more mass than the Sun, but they were only 10 kilometers across, like the size of cities. In their final moments, they were whirling around one another hundreds of times a second, traveling at a third the speed of light, rippling the fabric of space-time with gravitational waves until their intense gravity couldn't withstand the forces. They broke apart, merged together, and detonated, releasing the gamma ray burst, seen 130 million light years away. Colliding neutron stars detected by gravitational waves and confirmed by other telescopes. That's amazing, but it gets even better. And I'll get to that in a second, but first I'd like to thank Andrew Ledzinski, Patricia Pipkin, Joseph Salome, and the rest of our 793 patrons for their generous support. If you love what we're doing and you want to get in on the action, head over to patreon.com/universetoday. From previous observations, astronomers already knew that NGC 4993 was approximately 130 million light years away, confirming the predictions made by the gravitational wave astronomers. And this is amazingly close. The previous merging black hole observations were billions of light years away. The world's observatories watched the explosion brighten and then fade away within a few days. Astronomers realized that they were looking at a very special kind of short gamma ray burst, one which had never been observed before, a kilonova. Now, you've probably all heard that all the heavier elements in the universe were formed in the hearts of supernova explosions, when the force of the collapsing layers compresses lighter elements into heavier ones. But the models of supernova-generated heavy elements didn't seem to match reality. There had to be another mechanism at work. And one idea was colliding neutron stars. Only these events could generate and distribute gold, platinum, and other heavy elements into the universe. In the cosmic wreckage blasting out of the collision, astronomers detected the source of these heavier elements for the first time. The gold in your wedding ring, the precious metals in your cell phone, they don't come from supernovae, they come from colliding neutron stars. In a fraction of a second, an amount of gold equal to the mass of the moon was created. In fact, just one of these events generates the mass of the Earth in precious elements. So that's where it all comes from. This was a very big day in the field of astronomy. Astronomers were incredibly lucky to have two neutron stars collide so close to us. I know, 130 million light years doesn't sound close, but it was. Thanks to the 3 separate detections, they were able to determine its rough location to direct astronomers around the world. And by following up, they observed a kilonova for the first time, watching how these unique collisions spread heavier elements into the universe. We now have confirmation that our precious metals are formed in events like this. Since the gravitational waves and radiation arrived here on Earth at the same time, it confirms Einstein's prediction that gravity moves at the speed of light. By seeing the same event in both gravity and radiation, astronomers have a new way to confirm the speed of the expansion of the universe. As a quick side note, one cool part about this discovery is the massive collaboration that happened across countries, universities, observatories, and research agencies. In the end, 4,500 separate researchers were co-authors on the paper announcing the discovery. So what do you think about this discovery? Are there any aspects of gravitational waves, gamma ray bursts, or colliding neutron stars you'd like me to dig into any further? Let me know your thoughts in the comments. Of course, we'll need a playlist all about this amazing discovery and the related science. First, let's start with the original announcement from the European Southern Observatory and the announcement from NASA. Here's a video from Veritasium on the event, and of course Scott Manley is all over this. And finally, an overall explainer on gamma ray bursts from Crash Course Astronomy. That starts right now. Astronomers have made the groundbreaking, I literally